We're going to dive a little deeper into our asynchronous web request. And having already learned how to handle graceful errors that we get back from our web server or the API or web service that we're calling just by checking status codes, as well as checking for total errors on the API using these two event handlers, the onReadyState and the onError. There are some other really cool event handlers that are also provided by our XML HTTP request object that allow us to monitor the progress of data being loaded from the API or web service that we're calling. And in our XML HTTP request object, we simply use the onProgress event handler or event handler property by providing our event handler function, just like we did with our error handler and our return handler. So let's go ahead and create a new handler, a new function to be our handler, and that's going to be the API process, or progress, not process, progress handler. And so, of course, as always, these are just functions that we are using as event handlers. So this right now is just a name. We need to create a function for it. So let's do function, API progress handler. And in a progress handler, the cool thing is that it provides us with an object as a parameter that's called the event object. Inside of this event object, we have the ability to find out how much data has been loaded so far and what the total amount of data is that we should expect from our API call. And this comes to us from the web server. So let's go ahead and let's examine this event object just so we know what we're playing with. So let's just do a console.log and let's log that event just so we can go back to our browser and look at this and see what this object is. Here's our object. We've got actually that's not our progress. Here's our progress object right here. Progress object, and the big things that we have right here are the loaded property, which shows us about 14,000 bytes, and the total amount is 14,000 bytes. You can see these two numbers are identical. That means that the data provided here from our forecast API was such a small amount of data that really we got that data back super fast. Therefore, only one progress event fired, and all of the data, the total amount of data, was actually loaded right then and there in that first request. Now, the funny thing is that most web services nowadays don't allow you to pull massive amounts of data unless you are a subscriber and you're paying for the service. Being that right now we are using the free OpenWeather API and we are not paying for it, we can only pull small amounts of data from this web service. So right now we've got to talk theoretically about what this does for us and how we might use it if perhaps we were getting back megabytes worth of data and our progress event was being called multiple times before we got the data back. Now, how this would be useful is when we have a request to a web service and it is returning back to us a large amount of data that is going to take a substantial amount of time to return to us. So anything over a few seconds would be considered substantial when a user is waiting. What this allows us to do is we can actually calculate the percentage loaded and how much we have left, and we could provide that information to the user over here in our HTML. And we could, of course, do that through a pie chart showing how much we've loaded and how much is left. We can do it through a loading bar. We've all seen those loading bars where it shows you the percentage and has the little hashed lines, and they slowly move across the screen as stuff is being completed on our computer. We've all seen those, and the cool thing is that with this progress event, if we had a huge amount of data, let's say that this was, a million, or let's say 100,000 bytes instead of just 14,000, then we could calculate the percentage loaded by taking this loaded amount and dividing it by the total. And we can do that, and then we could update some HTML UI element, such as a pie chart or else a loading bar. And this gives us our user feedback, showing them that stuff is still happening, it's still working, it's just taking some time. If we didn't give the user feedback like that, what we would end up with is an impatient user that assumes it's not working or something's wrong. They'll reload the page and restart the whole web request again, and then they'll be waiting again. It's really important that we provide our users with some sort of feedback that shows them how we are progressing in accomplishing the tasks they're requesting from us. So although this is just a small amount of data, and this divided by this will always end up providing us with 100%, we're going to go ahead and we're going to go through showing how we might do this logic inside of our handler. And we can do that by taking and calculating the percent. So we can say percent loaded equals event.loaded. Let's make sure we're using the right one. Loaded. So event.loaded divided by event.total. And when we do this, event.loaded divided by event.total, that'll give us the percentage. And then down here, we would update the UI. So this would be a pie chart or loading bar with the current percentage. Right? And then, of course, every time this handler gets called, if we had large amounts of data, we would see these progress events being called over and over and over again. And each time it gets called, the loaded amount would increase, the total would stay the same. When we divide the two, we would end up with the percent loaded, and then we would update our pie chart or our loading bar to show the current percentage until it got to 100%. Of course, percentages calculated this way is going to be, it'll be 0 to 1, right? And that's what it'll end up being. So if we're at 50%, in that, it's going to be 0.5, right? Or if we're at 25%, it's going to be a 0.25. And that's because percentages, in this case, when we're calculating this way, are going to go 0 to 1. All right, so this is a really good event handler if you have some long-running web requests where you need to make sure you update the users so that they don't think everything's broken, and that they are kept in the light so that they don't restart the request over and over again thinking that things are broken when really they just need to wait till we're done loading. Extremely useful event handler when it comes to keeping our users informed, as long as inside of our HTML we go ahead and we have some sort of a pie chart or loading widget right here that we can update. Okay. So that is progress, checking the progress on this. Another important item that we have here, or ability that our XML HTTP request object provides us, is the ability to make sure that if we have web service calls that are super long running, or they are taking much longer than we expect them to, we have the ability to limit the amount of time we're willing to wait. And then once we reach that, we can actually cancel the XML HTTP request and notify the user that the web service just simply is not responding as quickly as we would like. And how we do that is we use the XHTTP, so our XML HTTP request object, and we use the timeout property and we set it to the number of milliseconds that we're willing to wait. So let's go ahead and say we're willing to wait for 2 seconds. That's as long as our users are willing to wait for data to come back. So this is time in milliseconds. So keep that in mind. These are milliseconds. Once we have a timeout set, then we can use another event handler So the X HTTP, and then we go ahead and use the on timeout event handler. And just like we did with all the other event handlers, this requires that we create our own custom function that will handle the event. So let's do API timeout handler is what I'm going to call mine. And of course, it's just a regular function that we are using to handle the timeout. So let's create a function with that particular function name. And it, just like the progress handler, provides us with an event object with some data on it. So let's do a console.log, and let's go ahead and see what our event object looks like for an API timeout. So let's go back to our code here. We've got our progress event, a progress event. Oh, look, right here, we actually see it happening. We've got the total, and we've got the amount loaded. And they're different. So we would actually be able to calculate a percentage right here. And then right here, we get the final amount with the final amount. So we could have been calculating the percentages there. Let's do that really quick just so we can see it in the future. Let's do a console.log. And if it ends up that the API takes a little bit longer than it has been, we'll be able to see what the percentage is. So let's do percentage loaded, and then let's go ahead and provide that percent loaded. Let's put a percent sign in front of it. Actually, it's just going to be in decimal first. We won't worry about changing it to a percent yet. Let's see if maybe we can get it to do it again. Ah, it did it again. Awesome. So console.log, about 92% was loaded, and now 100% was loaded. Excellent. I'm glad we were able to see that. Before, we were seeing that this request was coming back super fast, and we were getting 100% in the first load event. But now we're seeing we're getting multiple load events, as I was describing before, and we're getting to see the percentage calculated in decimal format. That's really awesome. All right, let's get back to our API timeout handler. So here we're saying that we're willing to only wait 2 seconds. And then we're going to go ahead and log our timeout event. Now, as you can see right here, we are not timing out because this is all coming back super fast, in much faster than 2 seconds. So that means in order for us to see anything happen, we're going to have to really dramatically reduce this timeout in milliseconds to something that we know the API can't keep up with. So I'm going to say 100 milliseconds. In 100 milliseconds, we should have a timeout. Here's our progress event. We have a timeout. And as you can see, it's a progress event because we're timing out, but it's being handled by our timeout handler. And this is the progress event that's being sent. It's a timeout. And if we look at this timeout right here, let's see what we got. 0 data loaded, no data coming back because it's a timeout. We didn't get anything back from the server. So this is really useful. 100 milliseconds, of course, is way too fast for the web service to respond. But if we have a really long running web service, so let's say our timeout is like 5 seconds, 10 seconds, that's just a really long time. And maybe we're calculating percentages and stuff like that. But if our timeout threshold gets reached, then our API timeout handler gets called. So with the API timeout handler right here, being that we know we have a progress event with a timeout, we're just going to go ahead and let the user right here know. And of course, we'd want to do this in the browser. We're going to console.log and then say the request has taken too long. The request has taken too long and will be terminated. All right, so now when an API request to a web service or web API is taking way too long, we can set the timeout to something reasonable. Of course, we're getting super fast responses from OpenWeatherMap, but if we were getting back huge amounts of data, or if a web service was taking way too long to respond, we would go ahead and set this to something reasonable, such as like 4 seconds. So 4,000 for 4 milliseconds. So for 4 seconds, we do 4,000 milliseconds. And then we would go ahead and add our API timeout handler. And then we would just go ahead and in here provide our user with a user-friendly message that lets them know that the request has taken too long, and then we're going to go ahead and cancel it. And then maybe we want to say, you may want to retry in a few minutes. That way you're not leaving your user in the dark, they're not waiting forever, and you can handle long-running or web requests, asynchronous web requests that are taking too long to return for the user. So this is really useful, our progress handler as well as our timeout handler. Make sure that you implement those on your asynchronous requests to make sure that you're handling those. Number one, you're providing users with feedback that shows them how things are progressing. That's super important. Think about yourself as a user. That's extremely important to you. And then also handling long-running API requests that seem to have just failed and are just taking way too long. Go ahead and make sure you implement an API timeout handler.